The Byrock project targets the porphyry drill targets we've identified this year through our new AirMag survey and ground gravity work. There's a couple of things that tell us that this is prospective for the same types of porphyry systems as North Parkes and Cadia. One is the age of the rock. So there's a geochron date that was taken from some 1978 drill holes, so 430 Benambran age, 430 million years old. So we know that we've got some rocks that are of the right age. We know from previous drilling that there's the correct type of intrusive rock there, a more felsic type of rock, and that we also see in one drill hole there, probably a near miss, there is a porphyry B vein, which is indicative of a porphyry system in the area. The other thing we see in the mags is that these porphyry, or what we're interpreting as potentially as porphyry, is that they have these big sort of blocky kind of intrusives, and they've got these little pipe-like features that sort of pop up, little pencil porphyry type of things, which is very indicative of the style of porphyries you see to the south in the Junai-Namrine volcanic belt and the Moilong volcanic belt down at Cadia. So there's some things in the geophysics that we see and some things in hard rock and the correct age. The difference up here is that we're under just very shallow cover, sort of 30 to, or sort of 40 to about 100 metres of cover. So there's not been a lot of exploration. It hasn't been recognised as a segment of the Macquarie Arc, but this drill program will give us the answers. So it's very exciting. We whittled it down from, we had 39 pipe-like features, and we chose 19 of them from their size, their depth, logistical sort of positioning, and some of the mag and gravity responses, and went, well, let's go out and we'll do gravity over those 19. We whittled that down to 9, and in the first program we've got 7 that we're planning to drill in the first pass program. So a lot of those are around the T47 target, where there's a sort of a larger sort of body or intrusive. It looks like a cluster. So PO2, PO1, P37 and P38 all sort of sit around the periphery of that. Looks very much like some sort of little porphyritic cluster there. So that's going to be really important to test those. And then we're going to move out to on the other side of a major shear zone and hit P28 and PO7. So testing different parts of the system as well. So that'll be our first 7 targets that we've ranked in, and we'll be getting after that in November. That's a great question. How representative are these high-grade sample results? Now, these were grab samples and pan-cons from the surface, so they're not actually representative of what the grade might be in a drill hole, but what they do tell you is what's the assemblage, so what's the breakdown of the heavy mineral components, and that's really important to know, because if you have 90% trash, some magnetite, goethite, some of the minerals that are not very valuable and not much of the valuable heavy minerals, then you're in not an area or a district that's probably as prospective for an economic deposit. But what we did get in the grab samples was a really good heavy mineral sands assemblage. So high value zircon and titanium minerals such as leucoxene, ilmenite, rutile. They're all the titanium minerals, and we got up to sort of 35% zircon in some of those grab samples. What the drill program will do is that we're going to go underneath that. We've got some mag features which could be old beach strands, where there's potentially that accumulation of heavy minerals and hopefully valuable heavy minerals, so that the aircore program will go through and drill down to sort of roughly 20 to 30 metres down. We're looking for things right near the surface, so it's quick and easy and cheap to dig up. It is a bulk commodity that we're dealing with. So that will, hopefully we'll get a first pass program, we'll get across some of those sorts of areas. We'll build out a facies map. So what was going on in that Eromanga Basin in that area, and hopefully hit some grade and be able to sort of test what those mag features are, as well as understanding the geology of the region. And the thing with heavy mineral sands exploration is it's actually a lot of it's not a direct targeting a lot of the time. It's actually air core drilling is what you do to kind of help define where the most prospective zones are, because you've got to understand where that paleo beach line was, where was that sort of high energy beachfront zone there, which would concentrate the heavy minerals. If the drilling is successful at Nilpinna, the pathline and timeline towards resource definition and potential development is around. It's very quick. You can go out and do a resource drill out in a heavy mineral sands deposit in a matter of a few weeks. So, but what we need to do is find where that high grade zone is, or find a high grade zone, and then come in and we can do the air core traverses quite quickly. If, for instance, the program we're undertaking at the moment is 4,000 meters, that'll take about 2 to 2.5 weeks to drill. And potentially that might be enough to define the start of a small resource. I'm not saying that's what we're doing on this program. This is a reconnaissance program, looking over large areas for some of that FASTIS modeling mapping, and trying to target some of those mag features. Resource definition through to potential development. There's quite a bit of metallurgy over a year or two worth of that type of work, and permitting. So permitting, that's a how long is a piece of string question, but it is generally quicker with something like heavy mineral sands, because you're not using chemicals in the processing. It's a water and gravity's recoveries is used to process a lot of the heavy mineral sands to get a concentrate, which can then be trucked across to the railway line and either sent down to Adelaide or up to Darwin. The major railway line is a couple of hours drive to the west of us.